Welcome everyone, and thank you so much for joining on time. Joining on time also indicates that you are very serious about it. Congratulations on them, and thank you so much for your great support. Today we are going to learn one of the important topics from the Lean Six Sigma statistics as well as from the Minitab training. The topic is multivariate analysis. And as the name indicates, multivariate, that means we are going to study multiple factors at the same time to see what is the impact on the outcome, right? So it's a topic I can say that it's a part of advanced statistics, but if you see the practical significance of it, yes, I'm also going to explain that what is the application of it, but this is very important tool when you are going to solve the complex or chronic issues. Okay, so let's go into the detail. At any point of time, if you are having any questions, you can put that into the chat box, and I'm ready to answer all your questions. Okay, so the first topic is introduction of multivariate analysis. So let's go into the detail of it and let's understand what is this multivariate analysis first. Okay, now the today's learning is going in stage wise. That means we are going to understand first what is this multivariate analysis, then we will understand what are the various terms and concepts into the multivariate analysis and why it is important, because when we are going to learn the multivariate analysis to interpret the results, we must know all the concepts into the multivariate. Then in third part, I'm going to explain what are the various multivariate tools that are available. And I'm also going to explain one of the multivariate tools with the help of practical example into the fourth part. Into the fifth part, I will explain what is a methodology by which you will learn all the multivariate tools with the help of practical examples and my mentoring support. And at the end, we will see what are your questions and what are the answers to all that questions. Okay, so let's dive into the first part, which is introduction to multivariate analysis. So let me share you the screen. Meantime, if you have any questions, you can put that into the chat box. Let me share you the screen. Can you see my screen? Yes, great. Thank you. So the today's topic, as I already explained, is a multivariate analysis. You can see the picture, the multiple factors we are going to study at one time. Now let's go into the detail and just understand the basics of it. What is a multivariate? Multivariate means involving multiple dependent variables resulting in one outcome. That means one outcome or one result that we are going to see is the outcome of many dependent variables. So we are going to understand what are these dependent variables. This explains the most of the problems in the real world are multivariate. For example, if we take the simplest example of weather, we cannot predict the weather of any year based on the just season, right? Because there are multiple factors like what is the pollution, what is the humidity, what is the precipitation, and there are many number of factors that needs to be considered to predict what will be the weather for a particular year, right? So detecting the weather is not just depending on one or two factors, is the combination of many factors, and we need to study all these factors so that we can predict the weather, right? That's why it is the multivariate. Now, if you go into the more detail to understand what are the practical scenarios, let's understand the sales. Sales of you take the any product or service if you are going to sell, then it is again depending on the many factors. Like what are the factors is depending on the category of the product. It is depending on the production capacity of that particular organization, particular plant, geographical location, marketing effort, presence of brand into the market, competitor analysis, cost of the product, and there are many number of factors on which the sale of that particular product or service is dependent. So we can see if you want to study the sales, then again it's a multivariate. We need to use the multivariate analysis in that case. If you go into the more detailed examples, like if you go for the example of COVID-19 that was happened, we can see in the recent year of COVID-19, data scientists predicted the cases in coming days, right? Now, how this prediction was happening? This prediction is again happening based on multiple factors. And what are these factors? These are the factors, but not limited to, like government decisions, government policies, public behavior, population, occupation, public transport, healthcare services, and overall immunity of the community, right? So it's a combination of many factors. In short, if you want to understand, this study can be implemented in any section of most of the fields. And if you want to understand the many complex problems, in that case, we need to use this multivariate analysis, these multivariate tools. So in short, I can say if you want to solve the problem that consists of the many number of factors or the outcome which has the combination of many dependent variables, in that case, we must use this multivariate tools, right? Is this clear to you? From the point in the discussion, I'm sure that you must got the clarity about, okay, what is this multivariate analysis at least? Yes. Thank you so much, Monica. Thank you so much, Atik. Okay, maybe your internet connection, please check. Atik, thank you so much for your valuable comments. Please look into your connection as well. Thank you. Thank you. Okay, so that's the importance of multivariate, right? So there are many number of factors affecting our outcome. Now let's go into the second part, which is now, what are the terms that we need to understand before learning this multivariate analysis? So again, there is a huge list of important concepts that we need to learn. I've covered all them in detail in my training program, but just understand here, what are these concepts? So here is a list of concepts that we need to learn. The first concept is we must know what is the variance and standard deviation. These are the metrics, these are the statistics which are indicating what is the standard or what is the variation into your data points. Then second one is we must know what is the covariance, eigenvalues and eigenvectors. These are the again important concepts because your interpretation of the results into the multivariate analysis is depending on these eigenvectors and eigenvalues. Then there is a principal components, factors. What is this meaning of principal components and factors? What is the dendrograms? Then what are these graphs, creep plot, loading plot, and score plot? What are these rotations and what are the square coefficients? So there are many concepts, and we are also going to take one of the example, I will explain some of the concepts into that. But if you want to learn in detail, it is really taking a time. Due to time constraint, I'm just explaining that as an overview. Okay, so these are the concepts that we need to learn. Anyway, as we are going to take the example, I will explain them. Okay, so these are the terms. Till the point, do you have any questions? Please put into the chat box so that I can answer your questions. Great, thank you. So let's go to the third part, which is about multivariate analysis tools. Now we understood that what is this multivariate, why multivariate analysis is important, why we need it. And then we had also seen, if you want to learn this multivariate analysis, some of the concepts, study of the some of the concepts is very necessary. Now, let's go into the detail to understand what are these multivariate tools, or when we are discussing about these multivariate tools, what are the tools it consists of. So we can categorize or we can group them into 5 categories, or we can say there are 5 important groups of this multivariate analysis. The first one is, this is based on how we are going to assess the structure of data by evaluating the correlation between variables. Let's say we are going to study the 10 or 15 or 20 variables. And if you are going to use the correlation between them to see what is the trend or what is the structure of the data. Now, this is called as a assess the structure of data, and that is done by evaluating the correlation between variables. Now, this group consists of 2 important tools. The first tool is the principal component analysis, and the second one is factor analysis. I'm also going to explain this principal component analysis to you in detail with the help of practical example. But let's understand here, when we talk about these 2 important tools, principal component analysis and factor analysis, actually we identify a smaller number of uncorrelated variables from a large set of data. Right? Let's say we are having the 10 or 15 variables. From that, we are also, from that entire variables, we are going to identify only 2 or 3 groups which are significant. And we are going to name them so that we can have the better decisions. right? So in principal component analysis, what we are going to do, we are going to convert the huge data into smaller number of groups. These are also called as principal components or factors in case of factor analysis. Now the second group is the item analysis. This is mainly dealing with the surveys. If you are having the data in terms of surveys, then we are going to use this item analysis. We can use this item analysis to see how reliably multiple items in a survey measures the same characteristics. For example, a customer relations manager for a chain of restaurants uses an item analysis to assess the questions in the customer satisfaction survey. In other words, we can say whether the survey that they are going to use to study the customer satisfaction survey, whether it is correct or not, or whether it is giving the significant results or not. The manager wants to ensure that the questions consistently measure the customer satisfaction. So that's a very important application of item analysis. Now let's go to the third part, which is the grouping of variables, and that is explained in terms of graphical results, right? Group variables in clusters that share common characteristics. Now, as a part of this, we are having three important types. The first one is cluster observations analysis. The second one is cluster variables analysis. And third one is cluster k-means analysis. Here we are going to group the variables based on their similarities. Classify observations into groups based on their similarities. Now, when to use which type? So there are some guidelines. For example, let's say if you are having no prior information, that means first time you got the data and you want to group them based on their similarities. In that case, we should use cluster observations analysis. Now, let's say if you're having some of the prior data available, that means we have some data and we know what is the background or what is the preliminary study that we have conducted into the history, then we can use cluster variables analysis. In third part, we are going to use when we are going to define how many number of groups that we are going to form, right? You can specify the number of groups or initial observations for each group. Then in that case, we can use cluster k-means analysis. This is the third group. Now the fourth group is about discriminant analysis. In many cases, we are going to see that yes, there are processes are capable, but still we are getting some defectives. And it's really hard to detect what is the root cause for it. The investigation and everything is getting more time, required more time. And in that case, we require some immediate actions. Discriminant analysis is a very powerful tool that we can use in such a situations. Now, what are these situations? For example, to evaluate how the predictor variables differentiate the groups. Let's say we want to talk about the defectives and non-defectives, right? So how we can define the particular product or particular service is defective or not. In that case, we are going to use the discriminant analysis. Evaluate how the predictor variables differentiate. Second, predict the groups of observations that have unknown groups. Predict the groups for observations that have unknown groups. That means if you got the observations, we must know in which category or which group it belongs. Determine how accurately the observations are classified into the known groups. So we can also check the accuracy. Depending on the eigen values that we are getting, we can say, okay, which is the most suitable group for that particular observation, right? So again, this is a very powerful tool. And here is an example. For example, a high school administrator uses discriminant analysis to determine which of the three educational tracks a student should be placed in. So there are three educational tracks like A, B, C. A is like the students who did not require any attention from the teacher. B, we can say some attention is required. And C, yes, very high attention is required from the teachers. And to group the students into these three categories, we can use the discriminant analysis. This is again very powerful tool. And the fifth group of these multivariate tools is called as correspondence analysis. Now, what is the application of this? Correspondence analysis is used to understand the relationship between many variables and to group them for easy analysis. These are having the mainly two types. The first one is called as a simple and multiple. As the name indicates, simple and multiple, we can see here. Simple analysis explore the relationship among variables, and variables are in a two-way table. Now, what is mean by two-way table? There is a one-way the table is having the two dimensions. One is the one variable and the second is having the another variable. We are going to use up to 2 to 4 variables. If you're having 2 to 4 categorical variables, then we are going to use simple correspondence analysis. For example, researcher used simple correspondence analysis to determine how 10 academic disciplines, right? Now, academic discipline is a one variable to each other related to 5 different funding categories. So the funding category is another variable. So we are going to see the relationship between these two categorical variables having their multiple elements, right? In that case, we are going to use simple correspondence analysis. Now, application of the multiple correspondence analysis is nothing but the multiplication of the simple correspondence analysis. This we are going to use if you are having the more than 4 categorical variables. Application, if you see, it is the same. Explore relationship among the variables and also the data is in two-way table. For example, a researcher used multiple correspondence analysis to examine how different categories of the automobile accidents may relate to each other. So here we can see there are many number of combinations, many number of groups that we are going to study here, right? And in that situation, multiple correspondence analysis is the most important tool, right? So these are the 5 important groups. In my training program, I have explained each and every topic in a very detail with the help of practical examples. So these are the 5 important tools, 5 important groups that we are going to study as a part of this multivariate analysis tools. Okay. Do you have any questions till the point? Okay, great. No questions. Great. So let's go to the fourth part, which is we are going to learn one multivariate tool with the help of example. Okay. So let me share you the screen and let's learn that. I'm also going to demonstrate you how we can perform that into the Minitab so that you can also have the understanding of it. So let me share the screen. So the tool that I'm going to explain is a principal component analysis. Now, what is the application of this? As the name indicates, principal components. So we are going to convert, we are going to identify, we are going to group the variables in such a way that we can have the maximum number of variation into same or smaller number of variables. The principal component analysis is used to identify a smaller number of uncorrelated variables, also called as principal components, from a large set of data. With this analysis, you create new variables. Now, these variables are also called as principal components, right? So we are having the new group of variables, and these are nothing but the linear combinations of the variables that we have observed or that we are using for the multivariate analysis. The goal of principal component analysis is to explain maximum amount of variance with the fewest number of principal components, and that's why this is very powerful. Let's take an example so that we can have the clarity about how much powerful this principal component analysis is. For example, a bank requires 8 sections of information from loan applicant, right? So this information consists of what is the income of that person, what is the education, age, residence time, work experience, savings, debt, and how many credit cards that person is using, right? Based on these 8 factors, the bank is going to decide whether they are going to give the loan for that particular person or not, right? The bank administrator wants to analyze this data to determine the best way to group and report it, right? So we are going to group all these 8 variables into the principal components that will make the bank to take a decisions very easily. The administrator collects this information for 30 loan applicants, right? Here, the administrator performs a principal component analysis to reduce the number of variables. As we are having the 8 number of variables, can we reduce it to the 1 or 2 or 3 so that we can have the minimum number of variables to take a decisions? The administrator wants enough components and how much? At least they should explain 90% of variation into the data. right? And that's why we are going to use this principal component analysis. Now we need to follow to perform this principal component analysis. So let me show you that data and how we can perform that into the Minitab so that you can also have the more clarity on that. Okay, so let me share you the screen. Okay, can you see my screen? This is the Minitab worksheet and which has the data for all these 30 applicants for these 8 factors, 8 variables, right? So let's go into the detail of it. It consists of the income, education, age, residence, how much duration of the employment, savings, debts, and how many number of credit cards that applicant is using. And this data is collected for 30 loan applicants, right? And now, instead of all these 8 variables, 8 factors, we want to group them as per their similarities so that we can have the decision making very easy to pass the loan, right? So let's perform this principal component analysis on this data. Go to the stat, then we need to select this multivariate options. And after that, we can select both of these options. We can also use the principal components or factor analysis. Application of both of these is a very same. Now, let's talk about the principal components. Summarize sample variation from many variables with a smaller number of principal components. In short, we are going to group all these 8 factors, 8 variables into smaller number of groups so that our decision will be much easier. Used to reduce the number of variables for analysis, such as multiple regression and cluster analysis. So click on that. Now here we can see we need to provide some data like how many number of variables that we are going to study. Let's say we are going to study all these 8 variables. To select, so select all these 8, income to credit cards, select. That means we are going to study all these 8 factors. Number of components to compute, we can insert here any number or we can keep it as a blank so that Minitab calculate based on their feasibility, right? So at this point of time, let's keep it as a blank. And there is a type of matrix. So there are 2 types of matrix. The first one is called as a correlation and second one is called as a covariance. Correlation type of matrix is used when scale of the variables is different. For example, if you see our data, income, for the income scale is different. Like we can see the minimum value we are getting here is around 21,240 and higher value is coming around something around 91,100, right? So there is a huge scale. And if you want to compare that with irrespective of the education scale, again it's a different scale because we are having 12 to 20 something scale. For age, again there is a different scale. Residence, different scale. Employee, number of years for the employment, again different scale. Savings, again there is another type of scale. So we can see the scale for all the factors, all the variables that we are going to study is not same. So we need to select this correlation type of matrix. If you are going to use the same scale like 1 to 10, right? In that case, we need to use covariance. If you click on the graph, there are 5 graphs are available like scree plot, score plot, loading plot, and by plot for first 2 components. And there is outlier plot. Once we plot these, I will also explain what is the meaning of them and how we can interpret the results. Okay. At this point of time, let's select all these graphs, click OK. That's it. So that is the input that we need to provide to the Minitab. Once we provide that input, click on OK so that we will get the output. Now, if you go into the detail, let's see what are the output we are getting. We got the one eigenvalue of the correlation matrix. Then we called all these principal components. And after that, we got these 5 graphs. One is scree plot, then score plot, loading plot, by plot, and the last one, there is a outlier plot. Okay, so let's go into the detail. I will explain what is the meaning of all these, the matrix that we had seen, and what is the interpretation of this graph, what is the meaning of them. Okay, so let's go into the detail of it. Till the time, do you have any questions? Is dendrogram multivariate tools Dendrogram is coming as an outcome of the cluster observation analysis. So we can say the outcome that it gives, it is like the how we are going to group the number of variables, right? So it's a very beautiful graph, and it also explain like we can talk about the family tree. It is going to indicate which variables are belong to which category, right? That's a really great tool. Thank you so much, Carlos, for asking this question. Great. Thank you. Okay, now let me share you the outcome into the presentation, and we have some discussion on that. Okay, so we have seen this. Yes. So this is the first correlation matrix that we got as the first outcome from the analysis, right? And here we can see what it consists of. It consists of all the principal components. So PC nothing but the principal components, and we got all these principal components. Now, if you see here, the first row is eigenvalue, and also that indicates how much cumulative percentage. Now, if you talk about the principal component 1, it indicates the eigenvalue as 3.5476. Now, what is this indicates? This indicates the variance. This indicates the variance. So we can see the first principal components has the huge variance or the highest variance compared to the other things. And if you see what is the contribution of this principal component 1, it's a 44.3%. So this first principal component is having the highest weightage that we can see. It's a 44.3% of the contribution into overall 100% of the variance, right? So we need to focus on this principal component 1. If you go to the principal component 2, its contribution is 26.6%. Its contribution is 26.6% and has a value for variance, or the eigenvalue is 2.1320. If you add the principal component 1 and 2 together, they are contributing 71%. Have we calculated this 71%? 44.3 plus 26.6. So that is coming as 71. If you look at the principal component 3, again it has a eigenvalue of 1.0447 and its contribution is 13.1. If you add principal component 1, 2, and 3, so all three come together explains 84.1% of the variation. If you add the fourth component, again it explains 6.6%. And if you add all these four, it explains 90.7%. Now, if you go back to the example, the administrator wants to see how many number of principal components that will explain 90% of the data, right? So here we can look for, or we can take a data up to the 4 principal components so that they are going to explain 90% of the data, right? So this is the interpretation of this correlation matrix. This is the same thing that I have explained. The first principal component has variance of 3.5476 that accounts for 44.3%. Second is 26.6% with a value of 2.13. Third, 13.1% with the value of 1.04. And then there is a fourth component. If you add the first three components, they are explaining 84.1% of the variability out of 100%. Now, let's go for the Eigen analysis coefficients. Now, if you see this principal component 1 and the variable, then what it indicates? It indicates what is the value of this principal component 1 and how it is calculated by, because these are also called as a coefficients. So if you multiply this coefficient with that particular value of that variable, then we will get the first element of this principal component 1. In short, if you want to calculate the principal component 1 value, that can be calculated by the coefficient of the income multiplied by the value of the income, right? So the fixed equation will be like this: 0.314, that's the coefficient for this principal component 1 multiplied by the income, plus 0.237 multiplied by education, plus 0.484 multiplied by age, 0.466 multiplied by residence, and in similar ways, right? Here it is a minus, so we can also see the value is coming as minus 0.067 into depth and minus 0.123 into credit cards, right? By using these coefficients, we can calculate what is the value for that principal component 1. Similarly, we can also calculate for that principal component 2, 3, 4, and so on. Now, the intent of these values, this coefficient, is that we are going to group them as per their values. Now, if you look at the 4 variables or the 4 coefficient here for the age, residence, employee, and savings, all are having the about the same value. That is 0.48, 0.46, 0.45, and 0.40, right? So the values are very close to one another. That indicates that they form the one group, right? So based on this coefficient value, we are going to group them. Now, if you go to the second principal component, we can see this debit and credit cards has the same value, around minus 0.58 and minus 0.45. So we can group them as a second group. And if you go for the third principal component, again, we can see these two values, minus 0.676 and minus 0.401. We can group them into the third principal component. Now, again, if you can see here is a minus 0.468. This value is again close to this. But as we have already considered the credit card into the principal component 2, let's talk about the another variable, and that is the education here. So if you consider these two variables, income and education, we can predict or we can have the third group, which is called as a principal component 3. Now, once we group them, we can name them as per their similarities. Please remember that we must have the subject matter expertise, subject matter knowledge, so that we can group them. For example, if you talk about the first principal component, that consists of the age, residence, employee, and savings, that can be termed as a long-term financial stability. The second principal component, debt and credit card, they can be grouped as applicant credit history. And the third principal component, income and education, that can be called as a income and academic qualifications, right? That means if the bank administrator wants to issue or wants to pass the loan for the particular loan applicant, then he should only focus on 3 variables. The first one is what is his or her long-term financial stability, what is his or her credit history, and what is the income and academic qualifications. That means instead of focusing on the 8 variables, now they are grouped into 3 principal components as per their similarities. So this is the power of this principal component analysis. Now, if you see how much important of each of these principal component, that is indicated by the scree plot. So we can see there are 8 principal components, 1 to 8, that we can see here, and there is eigenvalue. And it is always a pattern that first principal component has the highest value of the eigenvalue. Second principal component has the next eigenvalue compared to the principal component 1, and so on. And it is going to be deteriorated or it is going to be reduced. We need to decide up to which value we should interested or we should look for. For example, if you go up to the 4th principal component, we had also seen we are getting around 90% of the variation. Or if you end up to the 3rd principal components, that is also okay because we are having the 84% of the data, right? So we should focus or we should only consider how many number of principal components based on what are the results that we want. Okay, so this is the scree plot. Scree plot indicates distribution of the eigenvalue with respect to principal components. Now there is a second plot which is called as a loading plot. In that, the loading plot, the by plot, and the next plot that we are going to see, score plot, that are only for the first 2 components. And why it is so? Because we had seen only the first 2 components are having the highest importance compared to the other principal components. So instead of focusing all the principal components, we can just focus on first 2, 1 and 2, so that we can have the more results. Now, if you see the values of that coefficients that we had seen here, like principal components, the income is 0.314 and for principal component 2 is 0.14. So if you use these 2 value as an coordinates like x coordinate and y coordinate, then we are getting 1 point into this graph on the loading plot, right? And similar way, if you plot all these 8 variables onto this loading plot, we are getting the different lengths for each of the variables. Now, the length these variables are having, if you compare these similar lengths, they are going to be grouped. For example, we can see here, savings, age, residence, and employee. If you see the length of all these 4 elements or the variables, it's same. So they can be grouped into the one category or one principal component. The debit and credit card, they are on the other side, and we can also say have the same length. So they can group into the second principal component. And the education and income, we can see they're also having the similar length. So they can group into the third principal component. So just by looking at the loading plot, we can see how many groups we can have and into which or how many number of effective groups we can cover or we can divide our entire data. The next is about the outlier plot. This is very important because here we are going to use Mahalanobis distances method. In that, if there is an outlier, now what is outlier? Outlier means unusual observation. There is some problem or some error into the data collection. So if it is present, then there is a one line that will be plotted by this outlier plot. This is based on the Mahalanobis distance. And if your any points are passing this line, then we can call it as an outlier. The multivariate approach takes into account the different scales between variables and the correlation among them. For the loan applicant data that we had studied, we can conclude that there are no outliers because there are no points above the reference line. If any point that is going beyond this, then we can call it as an outlier, right? So based on this important graphs and outcome, we are having the very useful information that can be used to convert all the variables into meaningful principal compounds. Atik, yes, what is the question? Can you do analysis with SPSS2, especially creating these plots and graphs? Yes, that can be done into SPSS, but frankly, I'm not hands-on about the SPSS and I'm not expert into SPSS. I'm using the Minitab and Sigma Excel to perform this analysis. I'm so sorry for that. I'm not aware about the SPSS. Thank you so much, Atik. Yes, we can use that into the SPSS, this multivariate analysis, but how to do that, I don't have experience on that. I'm so sorry for that. Thank you so much. Okay, so with the help of one practical example, we had also seen that how we can use this multivariate analysis. Now, if you want to learn all these other important tools, if you want to learn all the multivariate tools with the help of examples and mentoring support, just visit this link, vijaysabe.co/multivariate, and we can learn and you can learn all the important tools that I have explained, all the multivariate tools with the help of practical examples, supporting data, and the most important thing is my mentoring support. You will be getting the lifetime access to this content, and still you are here, I can also provide you the one coupon code that you can use so that you can also get the 10% off on this entire program. Use the coupon code 10START. Okay. Now I have also explained how we can learn all these multivariate tools with the help of practical examples, supporting data, and mentoring support. Now, if you're having any questions, please ask that questions into the chat box. I'm ready to answer all your questions now. Please insert all your questions into the comment box. Or any comment suggestion that you have from the today's training, you can put that into the chat box. Okay, great. If there are no questions, then thank you so much for your valuable time. I appreciate that. And thank you so much for having such a great support to me as always. Let's learn another important topic into the next live streaming or into the next video. Thank you so much. Please take care.